Remember, every single video is uploaded to my channel, right? So you can go and take a look at the videos of the class just in case you want to, I don't know, study or take notes or finish the classwork or something like that. You can go and do that, right? All right, so new topic for today, polynomial functions. Let's begin with what this is, right? And maybe you guys remember about the word polynomials because you guys studied polynomials when you were in 7th grade or 6th grade, right? Do you guys remember this or not? Polynomial functions. Let's take a look at the first word. Polynomial. All right, maybe you guys don't remember about this. How about monomials and binomials and trinomials? Maybe, does that ring a bell? Okay, cool. All right, all right, all right. Now I see some heads. Now I see some thumbs up. All right, cool. So what are those? It's pretty simple. Monomials are simply one of these, one expression, right? We have a binomial when we have two expressions separated by an addition or a subtraction, right? Trinomials when we have three expressions separated by additions or subtractions. Remember that? Okay, so every single one of these, a monomial, a binomial, or a trinomial, are subcategories of the main one, which is polynomials. So you guys kind of know what is a polynomial, right? Now, also, when we were in 7th grade or 6th grade, we saw what is the degree of the polynomial. The degree of the polynomial is the largest power of x that appears, right? So the biggest exponent, right? Let's take a look at this. Let's jump right into this example. So in here, we have some polynomials that you have worked on in the past with me, and some that you guys haven't worked on in the past. Some you have and some you haven't. All right, so the first one is one polynomial that you have worked on. Let's see who tells me what is the degree of this polynomial. Remember.
1.
All right, cool. Thank you. I was expecting for you to write in the chat, but yeah, thank you. I don't know who did it. I think it was 2 people, but all right. You guys did it perfectly. The degree is 1. Now, for those of you who don't really know why, who don't really understand, but this is why 1. Simple. All you have to do is take a look at the biggest exponent in the x variable. So look, here we have our x variable, and here we have no x variable, right? So 1x and no x. So you're going to take a look at the exponent on the x. And as you can see, the exponent is 1. So that is the degree, right? All right, what is the name of this function? This is pretty simple. Does anybody remember? We studied this on the first term. Anybody? No, not at all? Thank you, Marino. You are correct. These are linear functions. All I'm doing is changing the letter m, the slope, for a, and c, the y-intercept, for b. But this is a linear function. Look, this is the slope and this is the y-intercept. This is a linear function. All right. How about the second one? Let's take a look at the degree of the second one. What is the degree of this polynomial function here? Anybody? Someone? Whoosh, okay. A lot of you. Thank you, guys. All right, so yes, the degree is 2. How did you know that? How did you know the degree is 2? It's pretty simple, actually. Because you are going to take a look at the biggest exponent on the x variable. So look at that. We have 1x in here to the second power, 1x in here to the first power, right? And then we don't have an x here. So the biggest exponent on the x's is 2. Beautiful. That is the degree. How did you call this type of polynomial, guys? Anybody? We saw this term. We have been working on this term. Both laws are correct. Danny are correct as well. This is a quadratic equation, right? We know some things about the quadratic equation. We know the y-intercept. We know the x-intercept, so the roots, right? Remember how to find roots? We know how to find the vertex. We know how to know if the parabola opens up or opens down, right? So it makes an U or it makes an N. Right? We know a lot of things from quadratic because we have been studying these two in the past, right? The ones below, we haven't really seen these. These are also polynomials, and everything you guys have studied from these previous two apply to the rest of these, right? So what is the degree of this one? I'm not gonna ask because this was pretty simple. Degree is 3. Degree is 3, right? The biggest exponent on the x variable, 3. How do you call this function? Now, I don't expect you know, but maybe you do know, right? This is called a cubic function because the biggest exponent is 3. This is a cubic function, right? How about the last one? Okay, the last one, the degree is 4. The biggest exponent is 4, right? How do you call that function? You call it quartic. All right, take a look at these guys. Look, this is a binomial because we have two expressions, two little thingies. Two, separated by a plus or a minus. Here, we have a trinomial. We have 3. So this is called a trinomial, separated by additions or subtractions. If you have this, but this is separated by multiplications or divisions, then this is not a polynomial. Every single expression, every single thingy, every single monomial has to be separated by additions or subtractions only. All right. Here we have a polynomial, right? 4 monomials, and then another polynomial, right? 5 monomials, right? 1, 2, 3, 4, and 5. All right. Cool, guys. Cool. Let's jump into some exercises. How do we identify polynomial functions? So let's take a crack at this. We have 6 examples in here, 6 exercises, and we want to know if these functions are polynomials or not. And if they are, we need to tell the degree, right? So let's begin with the first one. Let's begin with the first one. Everybody in the chat, please. We have 25 people. I want 25 answers. Please tell me, is the first question, right? For the first question, is this a polynomial function? Yes or no? Yes or no? Is this a polynomial function? Yes or no? But remember, if you say yes, you need to write down the degree, right? So you can say no, and that is it. But if you say yes, write down a number, the degree of the polynomial. Let's see. Okay, we have some answers now. All right. Oof, we have a lot of answers. All right. Okay, all right. All right. All right, guys, thank you. All right, so all of you will be correct. This is a polynomial function, and the degree is 4. Beautiful. Now, in this case, we only have one variable x. Remember in our previous example, we had a lot of monomials. Okay, sometimes that doesn't need to happen. Sometimes, like in this example, we don't have the x to the 3 and the x to the 2 and the x to the 1. We don't have those. It doesn't really matter. All we're looking for is that every single piece of monomial that we have is separated by additions or subtractions. In this case, we have a binomial, right? 1 and 2, binomial. And it's separated by a subtraction. So this is a polynomial. And the biggest exponent you can find is a 4. That is it. Beautiful. Let's take a crack at question B. Tell me, is this a polynomial? Yes or no? And if you say yes, remember, you need to write down the degree. All right, only 11 answers out of 24 people, 25 people, 26 people. I need you to try, guys. I need you to try, please. Don't make me go into the chat and see who's answering and see who's not. All right? Try, guys. Don't be lazy. Just if you're in the cell phone, activate the keyboard of your cell phone and tell me the answer. There, all right. So we have 18 answers out of 25 people. 25 people. A lot of people are not answering. Either those people are not here or you just don't want to participate. So let's see. The person who is not participating is going to have a -1 in today's classwork. How about that? Look at that. And now some of you are answering. Look at that. Now some of you are answering. You see? I have to condition your classwork, so your grade, for you to answer. Let's take a look at who's answering and who is not. Here. Teranzola, Parra, Padilla, Méndez, Moreno, Sofía Plazas, Torres, Rojas. Vale, Rojas.
Yes.
I don't see your answer. Let me see again. Maybe I missed it. Let me see again. Uh-huh.
Mister, is that la sigo haciendo.
Okay. Okay. Ramirez, all right, let's see. Felipe Andres, so the guy who just left, hasn't really finished the question as well. Lau. Lau Botero. Can you please write in the chat to Felipe Martinez? Ask the guy, please, why did he left? Maybe he's having difficulties with the internet, right? I need to know. I need to know. All right. All right, let's continue. So, B, is it a polynomial function or not? Let's see. Here it is. So, no. The question B, in the question B, the function g is not a polynomial function because this includes a root, right? Root can be expressed as fractional decimals. I'm sorry, fractional exponents, right? But we need those exponents to be natural numbers. So 1, 2, 3, 4, 5, 6, all of those. Even 0 works. But if we have an exponent that is a fraction or a decimal number, then that doesn't work. That doesn't work, right? So g is not a polynomial function. G is not. For all the people who said yes, now you learned something new, huh? Again, look. I am not calling names because you had a mistake. No, it's okay to have mistakes. Just learn and change for the future. But I am calling names for the people who don't try. Because if you don't try, you are not going to learn. You are not going to practice. All right? Let's continue with the next one. Question C. Tell me, please, in the chat. Is this a polynomial function or not? And if it is, you need to say the the degree, please. Only 18 people?
Profe, que a Felipe se le descargó el PC.
Oi. Thank you, Lau.
Que ya se conectó, que un momentico.
Thank you, Lau. Nobody else? 18 people? Man, are you gonna make me for real give you a -1 in this? Man. All right, 22 people. We are 24, so two people are missing. Let me just write down who is answering, and that's it. After Vale Moreno, Contreras, if you didn't answer, you have a -1 in my class today. There you go. All right, you have a -1 now if you didn't answer. All right, let's continue. I'm gonna accumulate, guys. I'm gonna accumulate these guys. So you now, some of you have a -1 now in today's classwork. Man, if you don't answer the next one, you're gonna have a -2 already. All right? Thank you to everybody else who is practicing, who is trying. Even if there are mistakes, don't hesitate about trying. Don't get scared about the answer, guys. All right. So C, the question C, that is not a polynomial function. That is not a polynomial function. Why? Simple, because we are separating one binomial by another binomial, right? They are separating these two binomials by a division. Remember, fractions are divisions. So in this, we don't have a polynomial because we need to have every single piece of the binomial separated by additions or subtractions. This is in fact the ratio of two polynomials. We have one over the other one. This is the ratio. Remember, fractions are ratios, right? So this is a rational function, right? This is a radical function because of the root, radical function. All right. Let's continue with the next one. Question D. Is the question D a polynomial function or not? In the chat, please. Tengo que ser claro con esto, mi niño. Mire que no le estoy poniendo mala nota a la persona que responde mal. No le estoy poniendo buena nota a la persona que responde bien. Le estoy poniendo mala nota a la persona que no responde porque no lo está intentando. All right. Let me copy the names of the people who answer. The last one is Vale Botero. Lau Vale Botero. If you answer after this lady, then you have a -1, sorry. Where is this? These are the people. We copy this, write it in a. Look, I want to write it here. These are the people who answered. These are the people who answered. If you're not here, you have a -1. All right, let's see. So question D. Well, that is a polynomial. That is a polynomial. Why? Why is that a polynomial, guys? Simple. This is called the zero polynomial function. It is okay to have this wrong because maybe you didn't know it, right? I didn't explain it. This one doesn't have an x. So the first idea, the first impression is, since this has no x, then this is not a polynomial. This is not a polynomial, right? No, this is an exception to that rule. This is an exception. This is a polynomial function. We call it the zero polynomial function. The only interesting thing about this polynomial function is that this does not have a degree. So what is the degree of this function? I don't know. It doesn't exist. The degree doesn't exist. We don't know the degree. The degree is undefined. We don't know it. We don't know what is the degree. All right? Beautiful, beautiful. From here on, let's jump into question E. In the chat, please, is question E. A polynomial, yes or no? If you say yes, you need to write down the degree, please. Okay. Okay, I'm gonna wait a little bit longer. And I'm gonna copy the names and see who answered and who didn't. Some of you have a -3 already. Would you believe that? Some of you already have a -3. I'm not gonna call names, but there is one person who constantly don't answer the questions. There's just one person, one of you. All right, let me copy this. Here and all right. All right, so for E, that is a function. That is a polynomial function, sorry. That is a polynomial function. All right. Now, that polynomial function has a degree of 0. Why? Because you can see, you can express the 8 as a times x to the 0 power. What is 8? What is x to the 0? How much is any number to the 0? Well, that is 1, right? Yes, Danny. That is 1. So what we have here is 8 times 1, right? That is what we have in here, 8 times 1. And 8 times 1 is 8. So by doing this, I am not changing the value, meaning this is a correct form of writing this polynomial function. The degree is 0. Congratulations to the people who said yes and 0. All right, last but not least, question F. In the chat, please. Yes or no? And if you say yes, what is the degree of the polynomial? Let's see. Are you okay, Samuel? Did you realize your mistake? All right. Let me copy the people who asked the question. Lesser people, lesser and lesser people. All right. If you answer after Omar Ramirez, you have a -1. All right. So, is this or not a polynomial? Let's take a look. So, I said at the beginning, if we
Profe,
had...
Tomás sí
Yes.
respondió.
What?
Que dijiste que -1 para Tomás y sí respondió.
No, I said if you answer after Tomás.
Ah,
Because Tomás was the last one. But thank you, Alba. Thank you. All right, so I said at the beginning, right? Polynomial functions have to be split by additions or subtractions, right? In this case, we have a polynomial function that is split with a division. So this is not a polynomial function. And in here we have one that is split by a multiplication. So the first idea, the first impulse is to say that this is not a polynomial function, right? But take a look at this. We can distribute we can do these operations and see what we get. So for example, in here we have x minus 1 to the second power. This is a binomial to the second power, right? We can expand that like this. We can expand that like this, right? And now, let me just cut this part. Now, if we do the distributive property, so this times this times this, and this times that, right? Distributive property, if we do that, this is the result. And look at that. Now, every single monomial is separated by additions or subtractions. So guess what? This is a polynomial function, and the degree is 5. All right, congratulations to the people who said yes. I don't think there was a single person who said the degree was 5, right? No. There were a couple of people. There were a couple of people who said the degree was 5. All right, congratulations, guys. In other words, divisions are a no, but only when you cannot perform the division. In this case, we couldn't perform the division. So that is why we just stop there. This is why we stop there. But multiplications, most often than not, we can perform the operations. So if we do that, we can see if this is a polynomial or not. All right, okay. So this is how you identify polynomial functions from the ones that are not polynomial functions. All right. H is a polynomial function of degree 5. Something other to know about polynomial functions. How to find the real zeros. Did you guys remember when we were playing the Kahoot game? Did you guys remember that? In that Kahoot game, I asked one of the questions. One of the questions was, what is another name for x-intercepts? Right? And another name was zeros. Another name was solutions. And another name was roots. Do you guys remember that or not? All right, cool. So we have 4 names. Wow, 4 names to call the same thing, x-intercepts, right? So this is what we are finding here. We want to find the x-intercepts, the solutions, the zeros, the roots of this polynomial function. Now, this polynomial function, if we expand this and do the distributive property, this is going to be a degree 3. The degree will be 3. So this is a cubic function, right? How do I know? Okay, because eventually, if I expand this, eventually I'm going to have a 2 over here, right? Eventually. And then eventually, after I do the distributive property, I'm going to have to do x squared times x. So that is x cubed. So eventually, the biggest exponent is 3. Now, I don't know the rest. I don't know how many other monomials we're going to have. I don't know the rest. But I know eventually the biggest exponent will be 3. So I know this is a cubic function. So how do we find the roots or the x-intercepts in cubic functions? All right, there are 2 ways. Number 1, you use your calculator to do that. And you graph this function. That is the first option. That is the first option. I'm going to explain how to do that in a second. But I like to do this by hand. So I'm going to teach you how to do it by hand as well. Step number 1, change the name of the function by a 0. Right? Sometimes the function is called g of x or h of x. Or simply y. Wait, come back. Simply, sometimes the function is like this. Let me replace something in black. Maybe sometimes the function is just y equal, right? That is the name of the function, y. That is the name of the function, y. So you replace that part with a 0. Everything else is the same. All right? That is step number 1. Why do we do that? Because we want to find the intercept with the intercepts with the x-axis. And this is the way we do that. This is the way we do that. We saw this when we were studying the general form of the linear function back in the first term. All the way back when we were in school. Hopefully you guys remember that. I do. I remember that. All right, from here, how do we solve this? Simple. We know that here we have two factors being multiplied. What is that? What are factors? All right, factor is a fancy word for multiplication. So we have one thing multiplied by another thing. So we have two things being multiplied. Those things are the factors. All right, so we have two factors in here. Since we have two factors equal to 0, we can split these two. One factor over there equal to 0, and then the other factor over there equal to 0. We did this when we were finding the roots of quadratic functions. Did you guys remember this or not? Some of you remember. Okay, so did you guys remember at the beginning of the class I said what you guys learned from linear and quadratic functions can also be applied to polynomials? Look at that. Look at that. Look at that. It's the same process. Look at that. All right, from here, how do we find then the solutions, right? We're finding solutions. We're finding zeros. How? Pretty simple. All we have to do is isolate the variables in each individual equation. So let's take a look at the first one. To isolate x from here, we need to get rid of the -1, the parentheses, and the exponent 2, right? We need to do that. The first thing we're going to move to the other side is the 2. But since the 2 is an exponent, we move it as a root, right? So this is what we have. Square root of 0 equals x minus 1. This is what we have. Cool, but what is the square root of 0 now? What is the square root of 0? Well, it's a number that multiplied by itself gives us 0, right? What is that number? Well, that number is 0, right? Because 0 times 0 equals 0, right? So the square root of 0 equals 0. A lot of zeros in this sentence. I'm sorry. All right, from here, how do we isolate x? Pretty simple. Just move the -1 to the other side with the opposite sign, right? So we have 1 equals x. And congratulations, we have our first solution, our first 0. Hago un paréntesis acá, ¿listo? Recuerden que cuando buscamos ceros, estamos buscando las soluciones de la ecuación. Una persona que no está poniendo atención hoy o que de pronto tiene algún tipo de dificultad con el inglés o este tipo de cosas dirá, profe, aquí dice encuentre los ceros, pero mire que yo veo acá la función en rojo y no hay ningún cero. Mire, aquí hay un 1, un 2 y un 3, pero no hay ningún cero. Pues no, buscar los ceros en esta función no significa buscar el número 0. Significa buscar las soluciones, las respuestas, los interceptos con el eje X, las raíces. ¿Ok? Este es el proceso. Este 1, esto va a sonar raro, va a sonar chistoso, pero este 1 es el primer 0. Porque es la primera solución que encontramos. Este 1 es uno de los ceros. De esta ecuación encontraremos el otro 0, la otra solución. Okay, so how do we isolate x from here? Well, all we have to do is move the +3 to the other side with the negative sign. So -3 equals x. And look at that. Now we have our second 0. So now we know the zeros of this function, the one in red, are 1 and -3. But do you guys remember how I said the zeros can also be called x-intercepts? Right, so if we plot the function in red, this one, I use GeoGebra for this. GeoGebra. You'll know GeoGebra, right? You'll know GeoGebra, right? So all I have to do was type in this function, and this is the result that I have, right? If we do this, what we have is that the zeros can be seen as intercepts. Look at that. Number 1 is right there. This is one x-intercept. Are you looking at this? It is right in the middle between 0 and 2. This is one x-intercept. How beautiful is that? How beautiful is that? And the other one, -3, it is right there. -3. This is another x-intercept, right in the middle of -4 and -2. How beautiful is this? Two zeros, two solutions are also x-intercepts. and we can see this by the graph, right? So I promised to you, I was going to teach you how to do this by hand and also by the graph, right? By the calculator. So I'm going to show it to you first in GeoGebra because I love GeoGebra. I feel like if you have access to that, you should use that, all right? You should. This is a lot better than the graphing tool of your calculator. So if you can do this instead of your calculator. But if you cannot use this, I'll show you how to do it in the calculator then. By the way, how do you access this? All you do is type GeoGebra online. Click there, and this is not what I was looking for. GeoGebra graphic there. There it is, right? There it is. So type on the second one, GeoGebra online, then the second one, and it's gonna prompt you to the graphing tool. Is this one. All right, how do we type in our function? Remember, this is the function we are looking for, x minus 1 squared. So all we do is parentheses, where is it? Parentheses, x minus 1. By the way, you don't have to use this keyboard. You can use your own keyboard, right? The computer keyboard, right? X minus 1 and then to the second power. Look at that. We have the first part. And then times x plus 3. So parentheses, where is it? X plus 3. And then close the parentheses. Look at that. I can eliminate this and look at that. That is the function. Now, you can see that my function is a little bit slower, but simply because I moved the scale, right? Look, the scale is from 2 to 2, right? 2 and 2. 2 and 2 and 2. The scale is 2. Here, the scale is 1. If I want to do that, all I have to do is scroll down a little bit. And look at that. Scale is 2 now. If I want to have the scale of 1, I'll just scroll up a little bit, and there it is, right? One intercept is 1. The other intercept is -2. But let's say you want to be sure. All you have to do is click on the intercept. Boop. Click on the intercept. Not working. I don't know why it's not working. Because I haven't pressed enter. All right, there. Look at that. If you press right on the point on the intercept, it's going to tell you the coordinates of that intercept. So this tool is absolutely fast. The solution is -3,0. For the zeros, for the solutions, we only take into account the x variable. So -3. Let's say you want to find the other one. So you just click there. 1. This even works for y-intercepts. Look, here is the y-intercept. If you click there, we're going to have 0,3. This is the y-intercept. This even works for local maximum and minimum. I think I explained this when we were when we were studying quadratic functions, right? What is the vertex of a quadratic function? Right? And we also said that the vertex is a maximum if it is in a form like this, or a minimum if it is in a form like this. Did you guys remember that? Right, some of you remember. Thank you. Paso un momentico al español. Entonces de pronto les digo, ok, encuentre los máximos de esta función. Y digo, ay, ¿cómo así los máximos? No, bueno, pues los máximos son el puntico más alto en estas montañitas. Si yo tuviese múltiples montañitas, porque puede ser, uno puede tener funciones así, uy, mira, como una, así la voy a graficar acá. Una función así, una cosa así, y aquí está el plano cartesiano. Pues aquí tienes un máximo, otro máximo, otro máximo, y ya está, se acaban los máximos. ¿Cuántos mínimos tienes? Bueno, pues aquí tienes un mínimo, otro mínimo y otro mínimo. Eso puede pasar, ¿sí? ¿Cómo se encuentran? Bueno, pues es la variable que está aquí en X. Aquí está un valor en X, ¿no? Aquí hay otro valor en X. Mira, aquí hay otro valor en X. Para las otras, mira lo mismo, aquí hay un valor en X. Aquí hay otro valor en X. Mira, solo el valor que sea en X. Y GeoGebra los encuentra tan fácil como hacer clic acá. Mira, aquí sabemos que está, míralo, aquí está el tope. Entonces, ¡pup! En X es negativo 1.6. GeoGebra es muy fácil. All right. So this is how you find it using GeoGebra. But let's say you don't want to use GeoGebra. You want to use your calculator. say you want to use your calculator, right? How did you find the functions in your calculator? Pretty simple. What you have to do is go to y equal, erase the functions that you may have there. I have this function because I was explaining some of the topic to 11th grade or 10th grade, I don't remember. So just erase that and type in the function that you are looking for. We are looking for this function, x minus 1 square, right? So in here, I just do parentheses, x minus 1 parentheses and then square, right? X minus 1 square. And then times x plus 3. So times x plus 3. Close the parentheses. There it is. That's the function, right? If I press graph, after a while, I'm going to have the function. Look, the calculator is still thinking. So just give it a couple of minutes. There it is. It's done thinking. Now we have an issue, right? Our function doesn't look anything like the one in GeoGebra, right? It doesn't look anything like that. Look, that is simply because we don't have the proper scale, the proper window. If I want to have a window like this, like the one in GeoGebra, I have to write that down. Look, in GeoGebra, I'm using from -4 to +12. So let's do that. Window, and then in window, right, we have the minimum will be -4 to +12, I said, right? And if I want the same scale, if I want a different scale, I'll just type different numbers, right? But look at this. I have a scale of 2, right? I'm moving from 0 to 2, from 2 to 4, from 4 to 6. That is a scale of 2. So in here, when it says x scale, I'm going to write down 2. There it is. And that was a mistake, right? Because I'm saying this is the this is the y scale, and I'm saying this is the x scale in here. So that's a big mix. That is a big mistake. All right, let me change it. So from -12 to +12. -12 to +12. There, scale of 2. And in y, I want -4 to +12. So -4 to +12. And again, a scale of 2. You can change this however you want. I just want to have this so that we have the exact, precisely graph, right? After you are done with that, press graph again. And after a couple of minutes, the function is going to graph the calculator, sorry, is going to graph our function. Look at that. Look at that. All right. Now, did I write it correctly? X minus 1 square, x minus 1 square, x plus 3, x plus 3. All right, things are correct. All right, so how do we find these, the intercepts in here? How? Pretty simple, guys, pretty simple. Take a look at the first one. We know that the first intercept is here, right? That is the x-intercept. And the second one is there, right? We know that one. We know that one. But we want confirmation about the values. That is what we want. So for the first value, we're going to go to calculate. Look over here. On top of the key, trace. To do that, to do calculate, you just do second and trace. And we are going to have every single option to calculate. We can calculate values. We can calculate zeros, which is what we want. We can calculate maximums and minimums, right? We can calculate a lot of things. So let's say we want to calculate the 0. So you just scroll down and then enter. Look at the screen. The screen is asking you for the left bound. What is the left bound? Left bound is a point in the graph that is a little bit to the left of the 0. Bueno, aquí paso un momentico al español porque aquí es donde se me pierde la gente. Resulta que la calculadora utiliza métodos de aproximación. Entonces, la calculadora no puede encontrar el número sin que tú le digas un poco de valores antes de que te encuentre el número, para que la calculadora pueda aproximar. Entonces vamos a aproximarla, la vamos a ayudar dándole un numerito a la izquierda del que queremos encontrar. Supongamos que queremos encontrar este límite de acá, este de aquí, este límite no, sino este 0 de acá. Entonces vamos a mover el cursor, mira que estoy presionando el de la izquierda, estoy presionando el botón de la izquierda, hasta un punto a la izquierda de nuestro 0. El 0 está como por aquí, ¿sí? Entonces, a un punto a la izquierda puede ser este. También puede ser este de acá. Alguno. Digamos que elijo este. Entonces, solo le presiono Enter. Mira, aparece una linecita en tu calculadora. Ahí ya encontraste un límite izquierdo. Pero la calculadora te pregunta, ok, ya me ayudaste con el límite izquierdo. Ahora ayúdame, por favor, con el límite derecho. Entonces, tú te mueves un poquito a la derecha del punto que quieres encontrar. Aquí no sirve. Ahí te moviste un poquito a la derecha, pero del límite. Tienes que moverte un poquito a la derecha del punto. Y sabemos que el punto está justo aquí en el intercepto con el eje X. Entonces te mueves un poquito más. Ahí puede ser, ese puede ser. A mí me gusta hacerlo un poquito más amplio. Te voy a ponerlo como por ahí. Enter. Tienes tus dos lineecitas. Esos son los dos límites. Y ahora te pregunta, hey, guess. O sea, ¿dónde crees que está? ¿Me haces un favor? Más o menos me ubicas más o menos. Acércame, porfa. Hazme el trabajo más fácil. Recuerda, la calculadora está haciendo procesos de acercamiento. Entonces, entre más cerca puedas tú decirle que está el punto, mejor. Más rápido te lo ubica. Entonces, vamos a tratar de acercarnos lo más posible a ese punto, a el 0. Sería como por aquí. Aquí ya me pasé, ¿no? Entonces, yo creo que este es el más cercano. Entonces, le presiono ahí. Después de un momento, te dice que el 0 está en el punto X negativo 3, Y igual 0. ¿Les dio lo que a mí, muchachos? Ok. Gracias.
Yes, mister.
All right. Thank you. So remember, the value of X is -3. Now, if you want to do both X-intercepts, so both zeros, you're going to have to do the same process, but for the other point. Remember, the other point is around here, right? That is what the calculator is saying. The other point is around there. So you just do the same process. Don't do what I just did. Don't just move the cursor hoping to put it exactly on top of the line. Oh, no, don't do that. Because sometimes the pixels are so small that you think the cursor is on the line, but it really isn't. And you're telling me a wrong answer. So don't just move the point. No. So let's say you want to find the maximum here. Oh, no, teacher, finding the maximum is simple. Look, all I have to do is move the cursor all the way up to the point. So there, that's the maximum. No, don't do that, guys. Don't do that. Look, if I do this, it looks like it is in the maximum. So the maximum is -2, 3.9. But we know that is a lie because the maximum was -1.6666. 9.48. Huh? So this is a mistake, guys. All right, this is a mistake. Don't do that. Don't do that. All right, guys. So this is how you find zeros, both with the calculator or GeoGebra and also by hand. Let's take a crack at another example. Example number two. All right. Find the zeros, so the solution, so the x-intercepts, so the roots of this function, the one in red. How are you going to do that? Step number 1, change the name of the function by 0. Step number 2, recognize how many factors we have in here. And we have 3 factors, right? We have 3 factors because one is multiplying by another one, and this is multiplied by another one. So we have 3 factors. Right? Remember, factors are just a fancy word for things being multiplied. So 3 factors. That is why the word factorization, that is why when you factorize, the topic factorization, that is why at the end you have a bunch of parentheses, because you have a bunch of factors. Factorization gives you factors, right? All right, from here, split this into 3, each for every factor. So you can do this with 4 factors, 5 factors, 11 factors, the amount of factors that you want. What is the degree of this function? This function is a degree 4. This is a quartic function, right? So we have 3 factors. All right. The first answer is 0. We know it already. We don't have to do anything. Look, we were so lucky that the first is already isolated. The first 0 is 0. For the second one, let's just isolate x from here. Pass the 2 to the other side as a root. I'm sorry, these are the factors, right? This is one, this is the other one, that is the third one, right? So in the in the second factor, to isolate it, pass the 2 as a root. We know the square root of 2 of 0 is 0, right? Then isolate regularly. The plus 1 is going to pass as a negative, and then the multiplication of 2 is going to pass as a division. So look at that. We have our second 0, negative 1/2. Negative 1/2. That is our second 0. We have 1, we have the second. For the third, again, isolate regularly. The negative 1 passes positive, and then the 3, which is multiplying, passes to divide. So we have our third root, our third solution. All right, these are the zeros. Find the zeros. These are the solutions. That's it. We're done. That's it. We can see the zeros as x-intercepts. So if I were to graph the function, again, I did this using GeoGebra. GeoGebra is absolutely simple. Every time you can, just use GeoGebra, please. Using the calculator is going to take you a lot of time. GeoGebra is immediately. We can see these functions, these zeros right there in the function. 0 is there. Negative 1/2 is this. And 1/3 is right over here. All right. Beautiful. Look, this goes to show that sometimes the solutions are fractions. Sometimes the solutions are decimals. Look, this one is a decimal. Negative 0.5 is a decimal, right? This one over here. Sometimes the solutions are repeating decimals. 1/3 is 0.33333333333. Right? Just because you have a weird number doesn't mean that you have a wrong answer. No. Believe your mathematics, guys. You're good. Believe your mathematics. All right. Beautiful. So this is how we do the exercises. Well, these type of exercises, right? I give you a polynomial function and you tell me the zeros. From the polynomial, you tell me the zeros. But what happens if I ask you the same question but backwards? Take a look at this question. Find the function, but I give you the zeros. How can we do that? How can we do that? Instead, in this question, I'm not asking you to find the zeros. No. I'm giving you the zeros already. I am asking you to work backwards and tell me which is the function. Can you do that? Well, yes. What you have to do is, like I said, work backwards. Look, this is the same process that we need to do, but we need to do it backwards. I am giving you the zeros. So let's say I'm giving you 0, negative 1/2, and negative 1/3. I'm giving you the zeros. To work backwards, you're going to have to find the factors. And once you have the factors, right? So find the factors. Look, working backwards means finding the factors. And once you have the factors, you can, what happened? Whoosh. Once you have the factors, you can multiply those factors to have the function. That is exactly what we are going to do. Let me move a little bit to the front, a little bit more. There we are. All right. So let's do that. From the zeros, let's try to find the factors. How? Pretty simple, guys. Take a look at this. If negative 3 is one of the zeros of the function, we know that because I am saying that negative 3 is one of the zeros of the function, right? So if negative 3 is one of the zeros of the function, then x plus 3. So with the opposite sign, look, negative 3, x plus 3. With the opposite sign, that is a factor of the function. Now, how do you know that? Why is that a factor of the function? Take a look at this. Because if this is a factor of the function, we can equal it to 0. And if we isolate, we find the 0. So we are, in fact, working backwards. Huh? How good is this? In fact, if r is a 0, so 2 or 5, any other 0, we can find the factor simply by saying negative x minus r with the negative sign. X minus r is a factor of the function, x minus r. So we know one factor already, x plus 3. Can you find the other two? Well, yeah. The other two will be x minus 2 with the opposite sign, right? And for 5 will be x minus 5. There are the 3 factors. All right, we have our 3 factors. Once we have the factors, all we have to do is multiply them to have the function. So the function is this: x plus 3 times x minus 2 times x minus 5. We are done, guys. We are done. That's it. Working backwards seems to be a lot easier. Finding the function seems to be a lot easier, right? Now, a couple of things here. Number one, these are not the only factors that we can have, right? Somebody can say another factor will be 2x plus 6. 2x plus 6. Because if I isolate 2x plus 6, the solution will be, again, negative 3. So we can change this factor by another one. We have infinite amount of possibilities. We have an infinite amount of possibilities for each factor. So this is not the only function that gives me these 3 zeros. No, there are infinite amount of functions. I'm just choosing to teach you this because I think this one is the easiest. I think this one is the easiest. All right? Okay, cool. Another thing to know. Look, take a look at the question. Find a polynomial function of degree 3. How do we know this is a degree 3? This one is a bunch of multiplications. We don't know this is a degree 3. Okay, but we can expand this, right? We can expand this. So you're going to take the function and you're going to do distributive property. This times this and this times that. This times this and this times that, right? You can do that. And after you are done with that, you are going to have something like this, right? You're going to have x squared. Let me do these multiplications real quick. Negative 2x, right? And then plus 3x, and then minus 6, right? That is the first multiplication. And then times x minus 5. This is awful. There, in parentheses, right? Okay, so after you did the first distributive property, you can now also do the other distributive property because we have another distribution here. We can do this by this, and this by this, and this by this, and finally this by this, right? And also with the x, this by this, and this by that, and this by this, and then the last one. If you do all of these multiplications, you are going to be, you're gonna have this multiplication at the end. This is the final presentation of the function. I did it, all right? So you can trust me. Maybe I have mistakes, right? So if you want to do it yourself and check to see my answers, you can do it. Maybe I have a mistake. I don't know. So now we know this is a degree 3. This is a polynomial of degree 3. Now we know it. Because look, the biggest exponent is 3. Now we are done, guys. Now we are done. Okay, we can check to see if this is a correct function. How? All we have to do is just graph it in GeoGebra or in the calculator. We can do that. But we don't have to. We can trust in our calculations, right? This is the end, guys. This is the final thing I want to teach you today. So from now on, let's jump into some exercises. We're not going to do these exercises. These are going to be for another day. What I want you to do now is to log into Alex. Please go to alex.com. And there, you're going to find the classwork, today's classwork. All right. Now, that classwork is for only 1 hour, but you only have half an hour. So I don't expect you to finish the whole classwork today. You can do 2 things. You can do 2 things. Wait for the other class, right? This classwork is expected to be finished in both classes. Half an hour today and half an hour the next class. All right? So don't be scared. Teacher, I couldn't finish today. I'm gonna have a 1 or 2. No, don't be scared. All right? Don't be scared. Just work as hard and as properly as you can for this half an hour. And the next day, the next class, we're gonna continue with this classwork. That is one thing you can do. Another thing you can do is, I don't know, maybe you like math, right? I don't know. Some of you do like math, so maybe you want to continue with the classwork. Look, I left the classwork open in case you want to continue working. But this is not a homework. Please, guys, don't go around saying that Mr. Quintero is giving you classwork, because this is not a classwork. I'm sorry, this is not a homework. I don't want you to do homework. I am one of the teachers who decides to don't give you homework, right? So please don't say, teacher, you are giving us too much homework. No, this is not a homework. You can do it if you want to, guys, but you don't have to. This is not a homework. All right. The reason why I leave this open, this classwork open for the rest of the day is simply for the people who has difficulty with the internet. So for example, Hade's having difficulties with the internet today. Okay, so when the internet comes back, she can do the classwork. Right? I know somebody else, Pipe something. Where is that guy? Pipe Martinez, right? Pipe Martinez is having difficulties with the internet. The guy comes out and comes back constantly. So for people like him, I am giving the opportunity to continue with the classwork after the day. But don't take it as a homework, all right? It's not a homework. All right, guys, remember, if you have any doubts, you can always ask me. I am going to mute myself now and let you work, let you concentrate. Bye-bye.